Hi, I'm Sherin BV, Assistant Professor in CSE Department from RMD Engineering College. So discussed about the topic is 8086 architecture. So here the first part of the architecture is bus. So bus means it is a group of connecting lines that carries data through the data bus, carrying address through the address bus, carrying control signals through the control bus used for read and write the data. Read means to read the data from I/O or memory devices to the microprocessor. Write means after the execution to carry the output to the I/O devices or memory devices. So based on the bus can be divided into 5 different types of buses. Data bus, address bus, control bus, CPU bus, and system bus. Data bus, it is a group of conducting lines that carries data. Directly move the data from I/O or memory devices to the processor and return back from processor to I/O devices or memory devices. Address bus, group of conducting lines that carries data through the address. Third one is control bus. So conducting lines that carry signals through the read and write, etc. Number of control signal is there. We will study in details about the control buses in instruction set. CPU bus. So group of conducting lines that carries the data directly connected with the microprocessor. So microprocessor directly connected with passing the information with the help of the CPU bus. System bus, group of conducting lines that carries data, address and control signal in microprocessor system to the text. That means to control of all the address buses like data, address, control and CPU with the help of common system bus. So 8086 microprocessor. So this is a diagram of microprocessor. So here in this diagram, it is an architecture diagram of 8086 microprocessor. So it can be classified into two different types. So first part, it is called a bus interface unit. The second part, it is called a execution unit. This bus interface unit, as a definition of the microprocessor, is fetch, decode, and execute. Fetch means to read the data. So to read the data directly from memory interface. So bus interface unit can be used for fetch the data and decode the data. Finally, execution done with the help of the execution unit. So bus interface unit can be divided into three types: segment register, instruction pointer, and instruction queue. So with the help of these three, we have to fetch the data directly from the memory interface. So decode the data. After fetch the data, decode it and send it. Decode it means so all the data converted to the machine understandable format. That means by zeros and ones format converted, decode it with the help of the control system. After the decoded, execution part can be divided into 4 general purpose register, 4 special purpose register, arithmetic logical unit for execution, operand, and the flag register. So we will discuss each and every topics. Bus interface unit. So it is a general definition of the microprocessor. Fetch the data, decode the data, and execute the data. Fetch the data with the help of the bus interface unit. So bus interface unit send out address from memory location. So fetches the instruction from memory. Read or write the data to memory. Send out address for IO port. Read and write into the IO port. So bus interface unit classified into three main parts: instruction pointer, segment register, and instruction queue. So instruction pointer, so it is a 16-bit register. So that keeps address of memory location of coming instruction to be executed. So number of instruction ready for the execution. One is executing, another one is ready for the execution. So once execution is completed, the next one is going to the execution unit. So that register, that means memory location of the coming instruction to be executed, that detail saved inside the instruction pointer. So we have to calculate the physical address of the instruction pointer with the help of this formula: code segment multiplied with the 10 plus instruction pointer. That means offset address. So offset address added with the segment register multiplied by 10. So we have to calculate the physical address of the instruction pointer. Next one is segment register. So 8086 architecture classified into four different types of segment register: code segment, data segment, stack segment, extra segment. So what is segment register mean? The memory spaces of 1 megabytes. So total size of the segment register is 1 megabytes. So entire 1 megabytes of data, the total size of segment register is 1 megabyte. So can be divided into four different types of register. So each and every register size is 64 kilobytes. So code segment for 64 KB, data segment for 64 KB, stack segment for 64 KB, extra segment for 64 KB. So total size of the segment register is 1 MB. Instruction queue. So the bus interface unit perform its operation in parallel with the execution unit. So microprocessor always to read the data parallelly. So it fetch the instruction byte while execution unit is executing the operation. So it is a middle part of bus interface unit to the execution unit. So here it's parallelly to send its data to the execution unit. The prefetched instruction saved in group of high-speed register is known as instruction register. Prefetched instruction. That is the proper definition of the instruction queue. The second part is execution unit. So what is execution unit? Execute the data. So fetch the instruction. Fetch the instruction means we have to get the data from the instruction queue. So fetches the instruction from the queue in bus interface unit, decodes and execute arithmetic and logical operation using ALU. Abbreviation of ALU is arithmetic and logical unit. Sends control signal for internal data transfer operation within the microprocessor. Sends request signal to bus interface unit to access the external module. So it operates with respect to the T states. So totally 4 clock pulse. 1 clock pulse means 1 up and 1 down. So here this is a 1 clock pulse. So one complete execution need 4 T states. That means 4 clock pulse combined, it is called a 1 T states. Okay, 1 clock pulse means 1 up and 1 down. So 4 clock pulse, it is called a 1 T states. So fetch the data, decode the data, execute the data. All complete process are done with 1 T states and not a machine cycles. So execution units can be divided into 5 different parts. General purpose register. 4 general purpose register: AX, BX, CX, DX. So next pointer and index register. So 2 pointer register, stack pointer, destination pointer. So 2 index register, source index, destination index register. Arithmetic and logical unit, flag register, timing and control unit. So these 5 is the main part of execution unit. So general purpose register. So a 4 general purpose register. Each general purpose register having a size is 16 bit. Okay, so here that is AX, BX, CX and DX. So one AX register is 16 bit. It can be divided into two 8-bit register. So A lower, A higher. Maximum size of AX register is 16 bit. AL register size is 8 bit. So 16 bit. The total size of AX register is 16 bit. It can be divided into two 8-bit lower order and higher order register. So it can be individually used for storing 8-bit data. So another name of this AL register can be called accumulator. Why it is called accumulator mean it can be used for to hold the data and to store the data. So that's why AL register it is called a accumulator. Two register can be combined to form a 16-bit register. AX register to hold operand and result, to hold the data or store the data at the same time to display to hold the results also. So that the reason only AL register it is called a accumulator. BX register only for holding the memory address, offset address. So with the help of this offset address, we can easily convert it as the physical addresses. CX register hold the, here it is also used for holding the data, but mostly for counting the instruction. So increment and decrement rotation, so that the situation we can able to use CX register as a counting register. DX register, so here it is also used for to holding the data at this sometimes multiply to 16-bit data multiplied, we are getting the data is 32 bit. So that maximum size of each and every register is 16 bit only. So the remaining extra digits we have to save some another register. So that the reason, that the situation we have to use the DX register. So during the multiplication and the division, arithmetic and logical unit, it is a 16-bit arithmetic and logical operation for execution. Special purpose register. So for special purpose register, so previous slide, these four it is called as general purpose register. So these four it is called a special purpose register. The first one is stack pointer, point to the stack. That means stack memory. Already we know that what is the use of the stack memory. It is a push the data and pop the data. So stack in is stack is in stack segment. So already segment register in the bus interface unit. So to point out the stack to take the data from the stack segment register. So here using during the instruction like a push or pop, call or return the data. Stack segment is the one of the segment register. Stack segment, one of the segment register in the bus interface unit. We have to take a data, push the data or delete the data, to call the data, to return the data to stack segment register with the help of stack pointer. Base pointer to hold offset address of any location in the stack segment. So it is used to access random location of the stack. Source index register. So it is also hold the offset address of data segment. So these two based on the stack segment. Source index, it is based on the data segment. It is one of the segment register available inside the bus interface unit to hold the offset address in the data segment during the string operation. What is the meaning of string? Collection of string. For example, hello. So here it is not a single byte, it is a collection of data. It is called a string. So in this situation, to hold the offset addresses in data segment. So destination index to hold the offset address of extra segment during the string operation. Similar. But here data segment, here extra segment. So stack segment, data segment, extra segment, it is the segment register supported by the bus interface unit. We have to get the data from the segment register, instruction register and instruction decoder. So it is used for to fetch an opcode from the queue into the instruction register. The instruction decoder decode it and send the information to the control circuit for execution. The second one is flag register. It is a 16-bit flag register. The total size of the flag memory is 16-bit, but 9 only we have to use. Remaining all are used for the future purpose, unreserved. Reserved for future purpose. So here among 9 flag can be divided. Totally 9 is a used flag. It can be divided into two types, status flag and control flag. So 6 status flag, 3 control flags. So 6 status flag. Remaining all are control flags. So here trap, interrupt, direction. Trap, interrupt, direction. These three it is called a control flag. Remaining all are it is called a status flag. So what is the first one is carry flag. What is carry flag? The flag is set. So size of the flag is only 1 bit. We have to save the data. So here when there is a carry from the MSB, if you are adding two numbers, no. So here most significant bit in the case of addition or in the case of subtraction, we are getting the borrow value. So that data, the maximum size of each and every register is 16-bit. If you are adding two 16-bit data, definitely we will get 17-bit. So extra 1 bit, the remaining most significant bit will be saved inside the carry flag. Next, auxiliary carry flag. This is set if there is a carry from the lowest nibble. Nibble means 4 bits. So that is bit 3 during the addition or borrow of lowest nibble. The lowest part, that means addition of AL, lowest bit. Okay, BL register. So here 8-bit data addition with another 8-bit data. So here lowest nibble value. So that time the extra bit will be saved inside the auxiliary carry flag. Sign flag. Okay. Minus sign and the plus sign. Okay, the flag is set when the result of any computation is negative. So that details will be saved inside the sign flag. Zero flag. If the result of the computation or comparison performed by an instruction is 0. If you are comparing two data, two register, CMP, compare two data. If the comparison is equal or if the comparison is not equal, so this output will not be displayed through the address. So it will be saved inside the flag memory only. Parity flag. So mostly used for this parity flag. So additionally, we have to add one more bit for encryption. So this flag is set. It can be divided into odd parity, even parity. So count the number of ones is odd. We have to add 1 as the parity. So count the number of values is even number. We have to add 0 as a parity bit. Overflow flag. Sometimes maximum size of each and every register is 16-bit. We have to push the data 17-bit means the extra bit will be saved inside the overflow flag. Okay, these 5 it is called a status. Sorry, these 6 it is called a status flag. Next, 3 control flag. So first one is trap flag. The processor entered the single step of execution mode by generating internal interrupt after the execution of each instruction. So we have to check some internal interrupt is occur or not. We have to check. If it is occurred, so the details will be moved to the trap flag. Interrupt flag. So here to recognize the external interrupt. So trap flag used for internal interrupt. So here it is called the external interrupt. So external interrupt is occurred means so that details will be moved to the interrupt flag. So with the help of the interrupt flag, so processor will be decided to continue their execution or stop their execution. So that is depends on the interrupt flag. Direction flag. So here if the flag bit is 0, the string is processed beginning from the lowest address to the highest address. So mostly it is used for string operations. So in the string operation mean the collection of data. So it will be moved in low increment wise or decrement wise. For example, the starting address is 5000 mean the next to automatically move the data 5001, 5002 like this or 4999. So it will be -1 or increment or decrement. That is depends on the direction flag. So trap, interrupt and direction flag used for a control flag memory. Timing and control unit. So control unit of execution unit, direct or internal operation and also responsible for the generation of control signal. So this is the architecture. 4 segment register, instruction pointer. So here instruction queue. These two can be used for to fetch the data. It can be used for to decode the data. After the decode, the data will be moved to the execution unit. 4 general purpose register. So total size is 16-bit divided into 8-bit, 8-bit register, higher order and lower order. So here 4 special purpose register, stack pointer, base pointer, source index, destination index. So that is based on the segment register. Arithmetic and logical unit, totally 16 flag memory, 3 is a control flag, 6 is a status flag. The remaining 6 can be used for future purpose. Thank you.